All right, so transformations of functions. What we're going to look at today is how we change a function. We'll move it. It doesn't matter what the original function is. Okay, that's quite good. We're going to just pretend that we're just talking about y equals fx. Now that fx could be anything, all right? It could be a quadratic graph, it could be a straight line graph, it could be a trig graph, it could be an exponential graph, it could be anything. But we can determine what it's going to look like or where it's positioned on the axes just by looking at what's happened to it. So, first thing we're going to look at is our original y equals fx plus a value. Oh, I've actually told you what's going to happen to it, which is a bit annoying. So it moves the graph, the original graph, by a units in the y direction. In other words, it's going to move it up or down. All right, so if this is our original function, okay, we don't know what the equation of this line is. It doesn't matter what it is. But if I were to draw the graph of fx minus 3, let's just say that, if this value was 2, okay, I know that my graph is going to move down 3 units. So this whole line is going to just shift down 3 units to -1, and it would be a parallel line to it. Do you understand what I mean now?
Yeah.
So that's the deal. Okay, so if there is a number stuck on the end of something, it means it's shifted it up and down, up or down, okay, depending whether it's a positive or negative value. You all got that? You haven't drawn it though. Alright, so this time, look where the value is that we're adding or subtracting. It's actually inside the bracket. So what's happening here is that the graph is not going to move up and down. So here it was stuck on the end. It moved up or down. Here it's going to move left or right. Okay, so in the horizontal movement. Okay, so it's going to go horizontally. However, if this is x minus a, it's actually going to move to the right. Okay, see I've got this arrow here. So if it's x minus a, it's going to move to the right. And if it's x plus a, it's going to move to the left. Now, the best way that I can remind you about that is, remember we were looking at quadratic graphs. So if that was just my x squared graph, if I had x minus 2 squared, hopefully you remember that it would look like that and go through +2. Do you remember that? When we looked at quadratic graph?
No.
Obviously not. If I had x plus 1 squared, it would go through here at -1.
No. Yes.
You starting to remember a little bit? Yes?
No.
Oh. Okay, that's awkward. If I had written that, because I've got x minus 2 squared equal to 0, it means that I've got a repeated root at the value of 2. Do you remember that that's where, and that's how we know it goes, where it goes through the x-axis. So it doesn't actually touch through the x-axis. It doesn't go through the x-axis, it just touches it at these opposite values. So it's always the opposite direction. I don't know if that's helped at all. Anyway, this one here, so if I was, whatever this function is, if this was x, I'm going to have to go minus 4, okay, then if this was my function, again, it doesn't matter what it is, you take a certain point that you can see or identify. So if I knew that this point here was 3, okay, I know that this point here is going to move across 4 units to the right. So that point is now going to become, let's say there. What value would that be? That would be a 7. Yes, do you hear me? So then what do we do? Well, we're going to shift all of our graph, that measurement, to the right. Oh, that wasn't a very good choice. Okay, let's move it loads. Don't laugh. Okay, I'm going to say this is -1, and I'm going to move it to 3. Okay, scale's rubbish. Okay, so I'm moving this point here to here. So everything is going to be moved that measurement across. Okay, so this point here is moved across this much. This point here is going to move that much. So then my new graph
See it?
looks like that.
Yeah.
Do you see how I drew it as well?
Yeah.
So I just took each position of the graph
I will go show
and moved it across that amount. Okay, once you've got those dots, you can then just join them up.
We'll get the tracing things.
Trace mover? No. Okay, so just be aware about the coordinates as well. So here we can see that our y coordinates haven't changed, but our x values have all had 4 added to them. Okay, so it might say this is the coordinate something, and what would its new coordinate be on the transformed graph? Okay, I have got a little table to summarize it in a second. All right, so we've looked at adding or subtracting a value to it. We've looked at adding or subtracting a value within the function. Now we're going to look at where it's multiplied by the negative value. Okay, so if we've got a negative value in the front, again, hopefully you remember, especially about quadratics, we know that they would be negatively sad, so they're upside down. Yes? Essentially what's happening is that they've been reflected in the x-axis. Okay, so if you've got a negative sign in front of it, it means it's reflected in the x-axis. So my bad boy here would be just that. Okay, and or I perhaps should do something more complicated than that.
There's one more complicated as well.
I know. However, I know you can't do this. But like if I had, so if I had drawn it like that, for example, then it still would be reflected in the x-axis. It just means that, oh, that's not very good.
Oh, got you.
Oh, some of it would be down below.
Right.
Are you hearing me, sister?
Yeah.
Katie?
So like the minus sign in front means that it's specifically reflected in the x-axis.
Correct.
It's like if you knew the value of f of x, it would be like y equals negative n1. So it's just like the y values.
Exactly, exactly. And actually thinking about what's happening to what effect does this have on it is exactly the reason there. Yeah. So if you were trying to find the value of y, you would stick your value of x into the function, la la la, but this negative is just going to make it the opposite, which is why it's going to reflect itself on the x-axis. So you may want to add this as an additional example, just to make it clear that it's not always just nice above and below, that they do sometimes overlap as well. So it just means it's a reflection on the x-axis. So this time, our x values haven't changed at all, have they? But our y values have all become the negative version of what they were before. Okay? So where this was negative, it's now become positive and vice versa. Obviously anything on the x-axis is where it was 0, so that doesn't change. This time, we're making our values negative and then performing the function on it. Okay? So what's happening here is that they would be reflected in the y-axis. Okay? So when your values are being negative before you do the function, before you apply the function to it, that's when it's changing it and reflecting it in the y-axis. Again, people don't always like reflecting stuff. Think about what we did just now for the translations. So I know that if I'm reflecting the y-axis, this point here is going to come over here. I'm going to try not to have 2 dots. This point here would come over here. This one would be over here. This one would be... Oh, that's not very good. Oh, shush now.
Shush now.
This one would be... maybe there. Is that all of them?
Yep.
Yeah. So then I'm going to go down... Oh, gosh. Up. down.
Yeah.
Oh, that's harsh. They're being rude though, my dog.
No, it just didn't add up.
Yeah.
What do you mean?
Where the dots were coming.
Yeah.
Oh, really? Do you want me to do that again?
Yes, please.
So we know a reflection means that this is our mirror line. Going back to good old-fashioned days, this is our mirror line. When we reflect something, it's got to be the equal distance, but the other side of the mirror line. Okay, so I'm going to stand. If I stand in front of you, it's not very helpful because you can't see. So this point here is going to be this measurement, but the other side. Yes? Obviously, it's going to go through 0, 0 again. That's good. So this point here is going to be this measurement, but this side. This one is going to be this long measurement. And this one is going to be even longer. Okay, so there's my points. And then I know the shape of it is like that. Alright, so this one here, we've got a number in front of it. Okay, I have told you, but do you remember, especially for the quadratics, what does it happen? What happens when there's a number in front of it? It stretches it. Okay, so it stretches it in the y direction. Okay, so the x coordinates are staying the same. Okay, so they're not being affected. It's just that the y values essentially are being multiplied by that number. Okay, so if we've got a scale at a, if a is 2, okay, so we've got 2fx, it's going to be double the height. So these points here are going to be the same when they go through 0, because 2 lots of 0 is 0. But whatever the value this was, we're going to double it. So it's going to be up here, this one's going to be up here, this one's going to be down here, down here. So I know that my graph is going to do this. Oh, look at that, that was quite good. This time what's happening is that we're doing something to our x value. So for example, we may be doubling our x value and then finding our y. So what's happening is that it's actually being, still say it's a stretch, but it's of a factor 1 over a. So for example, if I was finding f of 3x, then our graph would be 1/3 of the width that it would have been. Okay? Or look at me in face. Because it's a scale factor of 1 over a. Okay, so it doesn't get stretched by 3, it gets squished by a third. Okay? Because what's happening is that it's happening 3 times faster than it would have done normally. So when, it's often trig graphs are the easiest ones to talk about, but we haven't talked about them. So when normally I would plot this point here and here, because I'm multiplying my value of x by 3, what's happening is that that's going to happen 3 times faster than it would have done normally. Okay, so our y values again are not changing, but our x values are going to be squished by a third. So where this value could be a 3, this would now happen at the value of 1. Does that make sense? So it's a little, no, it's not like the 1/3 one. It just means that everything's going to be squished this much. So, oh, that's not really very good third, is it? Maybe it needs to be a little bit less. Is that a bit better? Maybe.
Oh boy.
Alright, the nice thing is you don't have to draw anything, write anything here, because I've done it all for you. So, here's a function. Okay, we don't know what this function is, and sometimes they will do that on purpose. They will give you a diagram of a function or a graph because they want you to know what's happening to that, not what you remember a certain graph looks like, or be able to plug it into your calculator. So, the first one they want you to sketch is f of x plus 1. So we have to remind ourselves what happens when we have something different inside the bracket. When we're adding on 1 inside the bracket, it moves to the left. So that's what we've done here. So originally, the graph went through the coordinates 1, 1, 2, 2. Okay? Here, look, we're going through 0, 1, and 1, 2, because it's shifted 1 unit to the left. Yeah, so whilst it looks very similar to it, the whole graph is actually just shifted left. Yeah? Fx minus 2. So our original function, subtract 2.
Of course.
So this one was in a bracket, so that was a left and a right. So this one's stuck on the end, so this one's going to go down 2 units. So again, we were all above the x-axis here, but look now, we've shifted down 2 units. And that's all that's happened to it, is shifted down. F of minus x was the reflection in the y-axis. So here they've reflected it in the y-axis. Yeah? Because you don't have to do anything. And this one was negative fx, so that was a reflection in the x. And then this one is the 2fx, so that's stretched the y values. Well, they doubled the y values and kept the x the same. So try and think about these kinds of words. Translated. Remember from GCSE, translation means pick up a shape and move it. Okay, so if you get fancy pants, use these words. But if not, just describe it as best you can. Okay. Right. So there's some examples for you. I quite like this little summary table I found. This is actually just, again, a summary. What is it actually doing to the coordinates? So if you've got fx plus 3, we know that it's going to shift the graph up by 3 units. What does it do to the actual coordinates themselves? Well, the x ones stay the same, and the y's add 3, and so on and so forth. So I'm not going to go through each one of those. You just use it as an example to you if you're asked about coordinates, and maybe just become familiar with it. Okay? This was another little summary thing I found. I like little summary things. Lots of fancy pants ways of writing it, but it's just everything we've talked about just now. It's just written in a slightly different way. And then there's some questions for you to have a go at. Okay?
Right now?
Yeah, sure.